on to our next keynote, talking about the disruptive potential of 5G. And for this, I would like to welcome on stage Karl Bream, VP of Strategy from Nokia. Karl. Thank you.
Thank you, Dirk. It's humbling to be here in Germany, the headquarters of Industry 4.0, at this pivotal point in time. Today, we're going to discuss the disruptive potential of 5G. And in order to do that, we're going to take a peek into the future first. 10 years into the future, when Industry 4.0 is fully realized. When we do that, we'll see that that future is a place of pervasive technology, of course. Thousands and thousands of machines and sensors will be feeding real-time information into an AI-enabled manufacturing platform. Autonomous mobile robots will be moving about the factory 24/7, improving productivity, and additive manufacturing systems will be in place. Likewise for mixed reality on the factory floor. But it's not just the scale of the deployment of these technologies that will be different in the future versus today. And this is important because it's that the technologies will be communicating openly and operating holistically across machines, factory, supply chain, and ecosystem. Because that's what it will take for new products to be developed in 1/10 the time, because production lines can be reconfigured very quickly, and there's real-time location of key manufacturing components that accelerate the process. Likewise, sustainability will be enhanced. Water savings of up to 80%, reduction in waste by 90%, and an engaged workforce that enjoys new digital skills mastery that they achieve through reskilling with mixed reality and holographic content. Outside the factory of the future, a completely autonomous, self-orchestrated, and self-optimized supply chain is operating. It's enabled with end-to-end visibility to ensure business performance and human safety. In fact, today's December peak in logistics and supply chain that happens will be enabled every single day in the future, because things like autonomous mobile robots will be able to process that volume of package and cargo much more quickly. Of course, that volume and that speed is only possible due to the enhanced predictability and low latency of 5G. And maybe 6G. It's 10 years in the future, after all. In that future, analytics engines will optimize picking routines as well as optimize delivery routes in the logistics and distribution business. And of course, in the last mile, autonomous and remotely controlled trucks, delivery bots, and drones will get the product to market. But the future of Industry 4.0 isn't all about advanced manufacturing and supply chain. In transport, imagine trains traveling at 400 to 500 kilometers per hour. This is faster than today's fastest train, which runs from Beijing to Nanjing in China at 350 kilometers per hour. These trains in the future will have limited operational interruptions due to time-to-event maintenance predictions about the train. And of course, passengers will be on the train and will be comfortable and safe with reliable connectivity that they use to work and play. Of course, You wouldn't be here today if you didn't already know that we're on a journey, a digital transformation journey to that future already. But it's not the same digital transformation journey that other industries have taken. Historically, other industries have replaced physical assets with digital goods. Think Amazon and Apple in books and music. But we're not in information and media-centric industries. We're in asset-intensive industries, and our machines and our assembly lines and our factories and our rail systems can't simply be replaced with digital goods. But we can still create significant value by taking digital control of those physical assets. We control those physical assets with digital programming, such as digital twins, process twins, factory twins, and digital threading. Of course, all that means more information, more analytics, and more predictability will be required to get efficiency gains, productivity gains, improve customer satisfaction, and improve safety. But to achieve that level of digital control, we need to elevate the level of reliability, predictability, and performance of the networks that connect the machines, the factories, the supply chains, and the ecosystems. Because that level of performance, reliability, and predictability has not been the focus of today's information and communications technology. In fact, today's wireless IT doesn't run autonomous mobile robots any faster than a human can walk. In fact, some experiences suggest that it takes 2 autonomous robots to do the work of 1 human. Wireless IT is typically not as reliable as needed either. We get 2 nines, maybe 3 nines of reliability, 99.9% reliability. But of course, in industrial operations technology, mission-critical processes, we're going to need 6 nines, 99.9999% reliability. And so what we're going to need to do is to converge ICT and OT to deliver the value of those industrial mission-critical applications and help them perform at the level they need to perform. It's at the intersection of ICT and OT that the disruptive power of 5G sits. It's the reason why many say that 5G is the catalyst to Industry 4.0. Now, forgive me, I'm going to get a little technical now, but I think it's important. It's important to go beyond the headlines that are out there about 5G and get down to the nitty-gritty physics of why there's a disruptive potential with 5G. And that disruptive potential follows essentially 3 dimensions. The first dimension is capacity. There's a 10 times capacity increase with 5G over today's wireless technologies, 10 gigabits per second per device versus 1. And this is important. That level of performance doesn't decrease as quickly as other wireless technologies do as you add devices to the network. The second dimension I talked about was reliability, 6 nines performance, and that's spread over a larger geographical area and is supported with military-grade security. The third dimension is latency. This is another order of magnitude shift that 5G brings, moving from 10 milliseconds of latency down to even 1 millisecond of latency. Now, I get a question when I start to talk a little bit technical, which is, how do I know if my use cases actually require that technical level of capability that 5G will deliver? We've developed some simple ways to tell. First, let's take a look. If your site looks a little bit like this, you're going to realize the disruptive potential and the value in 5G. Why is that? What do you see? Well, you see a process manufacturing plant, probably petrochemical, but look closer. What you see is reflective metallic surfaces. Reflective metallic surfaces degrade the quality of non-industrial grade wireless. Industrial grade wireless overcomes this degradation, and 5G makes it that much more powerful. And so if you see this in your operations, you probably need 5G. Let's take a look at another one. This one is probably a discrete manufacturing plant. It probably has heavy industrial robots and welding devices like the one shown. If your plant looks like this, you probably need the disruptive potential of 5G because these heavy industrial robots emit electromagnetic interference, EMI. And guess what? EMI degrades the performance, the reliability, and the predictability of non-industrial grade wireless. And so in this case, 5G, its industrial grade wireless capability, will deliver what you need. And so if you have heavy industrial robots, then you probably need 5G. Lastly, let's look at one more. Here, an automotive plant. In this one, we've sort of depicted in this automotive plant that there's many devices sending data. Why did we do that? Because if there's many devices sending data, the performance of your non-industrial grade wireless network will degrade, just like the others. And so if you're connecting a large number of devices in your industrial setting and have massive machine connectivity needs, you'll need 5G. But let's go back, because it's fun to look at things simply sometimes, but we can always go back to the physics. Because what you see in this image is performance testing of a Wi-Fi network as published by the IEEE. And what you see on the horizontal axis is as the number of devices go up, left or right, the saturation of the communication channel on the vertical axis goes up, meaning more and more saturation. And so we've added a number there to the picture, 16. That's the number of devices before the saturation sets in on Wi-Fi networks. Of course, if you live in an apartment building with 100 units, you probably already know that. So it's not that surprising. The same number, by the way, in industrial grade networks like 5G is 800 devices, maybe more. And that's an example of real performance in an industrial setting, in an industrial use case that you need. While 100% of the benefits aren't fully available, the path to 5G starts today, because I know that many of your use cases can be solved and you can start creating value now. Let's look at a few examples. Take Nokia's Oulu factory of the future. What results have we seen from deploying technology today? Well, at our plant, we're a manufacturer too. We manufacture 4G and 5G radio, as you might expect. We deployed the technologies that I've talked about, some of them today, as well as partner technologies in that factory. And we've experienced great results so far. We've experienced 30% increase in productivity year over year. We've experienced 90% reduction in production line setup times. We've experienced a 50% reduction, that's Six Sigma for us, in process defects. We've increased our overall equipment effectiveness. And we were humbled last year when the World Economic Forum awarded us the Advanced Fourth Industrial Revolution Lighthouse Award for our Oulu factory. But of course, it's not just Nokia. 5G is becoming a reality in other customers and other settings as well. At the end of 2019, we announced the world's first future railway mobile communication system. There's an acronym for that, FRMCS, based on 5G technology. Together with Deutsche Bahn, we are building an automated rail operation here in Germany, Hamburg, the S-Bahn. It will make automated and driverless trains a reality, starting with line 21. This is a fantastic example of the disruption that 5G can bring. And of course, we are very proud to have joined forces with Bosch. We started working with them through our Bell Labs organization several years ago. And our companies have been working on some of the technologies that I talked about today, like 5G in autonomous robots, like 5G location and positioning. We also worked on 5G emergency stop for machines. In 2019, we launched the vision for the intelligent factory of the future with Bosch, which focuses on areas like flexible manufacturing, improvements in productivity, universal wireless connectivity, and reduced setup times. And now in 2020, we're set to build on that, with the first project being a scaled 5G campus network at a Bosch factory here in Germany. What are our experiences so far? What's the key takeaway for you in what we've done so far in customers like these? Well, I'd say it's not the technology. It's not 5G alone that makes the difference. First, it's industrial know-how. Nokia's been at this for 2 decades in some of these industrial segments, and we've built a base of know-how that's hard to replicate. Yes, we have technologies like 5G and hyperscale networking, but we implement them through services that deploy them in manufacturing processes and workflows. But I'd say the most important lesson and the most important thing is the thing that permeates all of those, which is the ecosystem that holds them together. And we've been continually building that ecosystem at Nokia. We have industrial partners like Bosch. We have cloud platform providers, system integrators like Microsoft. We have service providers like Vodafone. We believe that a set of leading partners like the ones you see can deliver on that vision that I talked about in the very beginning of this presentation for the future. Make no mistake, 5G will disrupt. 5G will create value for Industry 4.0 leaders. Now is the pivotal point. Germany is the global industrial leader and will set the stage for the rest of the world. Nokia is excited to participate. I want to thank you for your attention today, and I especially want to thank Bosch for our continuing partnership in the area of 5G and Industrial 4.0. Thank you.